Many thanks everyone for joining and good morning. It's great to be as part of Sheffield Digital Festival. Although I very much look forward to doing some stuff in person at the next one, hopefully. So let's start with BJSS. BJSS are an IT and business consultancy. We've been around for 28 years now, and we've had an office in Sheffield for the last 18 months or so. Now, amongst our core values are building long-term relationships with our clients, and in order to do that, we must ensure that our solutions are delivered to time and to a high level of quality. Quality in software can be quite difficult to quantify, but one aspect is certainly the maintainability of the code base, which is the subject of this presentation. So to introduce myself, I'm Ricky Bearfield, and I'm the engineering lead for BJSS in Sheffield. My day job is as a technical architect, so I'm responsible for the technical quality of a particular project. I tend to code, so around 20 to 40% of my time, depending on the project, I'll be coding. And both my role as a technical architect and as my Sheffield role as well put maintainability and quality at the heart of what I do, and that's very important to me. So just to get things started and to try and make this a slightly interactive, I'm just going to show you some code. We all like to see a little bit of code. Now, before I start, and I ask you to comment on this, the first thing to say is that this is an open source piece of code. As we know, open source provides a huge benefit to individuals and companies, often without very much in return. Now, this example here is taken from an open source project from which we as a company have benefited, and has been extremely useful for one of our clients as well.
Really sorry to interrupt you, Ricky, but your sound is kind of coming in and out a little bit. I don't know if it's...
Is it? Thank you. I did have a couple of issues with it earlier. Just give me 1 second.
Okay, we should be okay now.
Yeah, all good.
All good. Okay, sorry about that. I'm not quite sure what you've heard, but I just wanted to talk a little bit about open source to start with, and just to say that this example I've put on the screen is something we've found to be extremely useful, and the pressure that open source developers are often under can be enormous. And I've got no information whatsoever around how this code grew over time, and the pressures the maintainers may have been under, and the fact this code is open source, apart from being able to use it and give back to it, it also means that we can talk about it. So it is massively useful to us. So what I wanted to do is just say that looking at this piece of code, I do have some concerns about how we could maintain this. So using whatever's available to you, I think the Q&A is definitely available to you, if not the chat to panelists. Is there anything about this code, and be as brief as you can, that you would consider something we'd need to look at or consider changing? So I'll give you a couple of minutes to have a look through the code base, or that code fragment, and just let me know via one of the mechanisms on Zoom what your feeling or thoughts are, or any things you'd like to point to. Hey, has anyone got anything that they'd like to share? Any parts of that code that they'd be concerned with? Yeah, there's a couple of things coming in. Just give it another 30 seconds for you to have a look through. Yeah. Okay, so I'll pick up both the points raised. So one point that's been raised around the switch statements, I'll come on to them. They can be a little bit Marmite sometimes with people anyway, but the specifically the cases within them, and just the basic length of the method. And by the way, this isn't the end of the method. So let's take a look through. So firstly, yeah, those case statements, they are hard coded. Now, to provide a little bit of background, this is part of a validation library for FHIR, which is a messaging mechanism used predominantly in healthcare. Now, the case statements here are all different versions of the standard. So what's going to happen when we get a new version of that standard? We're going to have to add a new case statement, which is definitely going to break our open close principle. So it's not a great thing. The next thing is actually the content of those cases. They're all remarkably similar. If you take a look through, it's almost the same words in every single case. So there's definitely some repetition there. It's just using a different value set class. There's different packages in each one, but other than that, it all looks very similar. So that's, you know, if one changes, they're all going to have to change. We might make a mistake, etc., etc. The next one is just this this if block for me. This wasn't one that was mentioned in the chat, but I like to read an if block and understand what the business purpose of checking was, or at least the system's purpose of checking. In here, I need to know I'm checking whether the option it's not inferring a system, and I'm checking whether the co-system URL and version to validate is not blank. Now, for me, I'm not quite reading why we're checking that in that if statement. So I'd love to see that extracted out, given a nice name, telling us exactly why that's important to us. The next part is the number of parameters in this method. The more parameters you have, generally, the more paths of execution in the particular method. And again, the harder to maintain. So, you know, we generally prefer less parameters. It's got quite a lot. This one is quite I guess a personal one, a subjective one, but I think I've highlighted one line too many there. But the first 3 lines highlighted there are initializing variables to null. That means we're definitely going to mutate them. And I prefer not to have to mutate variables. And that's, you know, a general practice of having as much immutable code as possible means that it's easier to reason about. So that style of coding, I'd prefer to do away with and introduce a more functional approach. I think the last one, there's a couple of terms being used here: case sensitive and flatten and convert codes DSTU2. Now, those 2 things used in this same method confuse me, because whilst case sensitive is something that from a business point of view, we can really easily understand. You know, if I'm validating messages, and if I said, you know, should it be case sensitive or not case sensitive, that makes business sense. So that's a business term being used up here. Whilst down here, we're using something which is really a much lower level coding concept, flatten and convert, which you know, from if you think about functional style, we can probably understand what flatten might be, and certainly convert, but it requires a different level. It is at a different level of abstraction. So we'll come back to that as well. A few stats about this code. This was 673 lines in this particular file. Now, as part of the work I've done fairly recently, I delved into this and debugged through it a little. We did find a couple of issues, and I'd love to have opened a PR and sent this stuff back. We did manage to fix those issues for our particular usage, but given the structure of the code, I wasn't really able to determine with any certainty that the fix I had done wouldn't break other usages of the code, which was a bit of a shame. And you know, that's part of why it's important to have a maintainable code base. Okay, so moving on from that quick session, what does make a code base maintainable then? So good, clean, and simple code, absolutely. The best code you'll see is the simplest code. The code can definitely not be clean if it's not part of a clean architecture. And And code should be flexible. You know, we don't want to have to rewrite it when we want to make a change. But equally, it can't be flexible in every possible way, because you know that's when you start trying to, when you intend to write a calculation and instead you code Excel, right? You don't want to do that. So you need to make it flexible in the right ways. Now the right ways is interesting, because right ways requires us to have an understanding of the business, possibly an understanding of the portfolio. It requires business people and developers to work together daily throughout the project, which isn't my words. It also has a ubiquitous language, so you can understand it without having to do any mental translation. We can hopefully just read basically the code and it makes business sense. And it's surrounded and part of a necessary and sufficient documentation, so you know it doesn't sit alone. There's some of the things that make a code base maintainable. Something else is following some sensible code design principles. So I wanted to have a quick refresh on just a few. Why do we follow them? Often it's not really said. So the what they are is stated. How to implement them is sometimes stated, but not why they're important. And I think it's somewhat based on experience. It's experience of not following these things that makes us follow them. But yeah, it's very difficult sometimes to say exactly why we'd want these things to be, but try not doing it for enough time, and you'll see how hard it is to maintain code. It's, you know, buggy, difficult to onboard into when you don't have single responsibilities in classes, when you actually say, oh, that's that same class that's now hundreds of lines long. So various reasons why we should follow them, but maybe it's not straightforward. First one then, I think everyone's sort of first coding principle maybe we learn is single responsibility. So every class should have responsibility for a single part of the functionality provided by the software. Simply the code does one thing, right? Each bit of the code does one thing. And when we need to maintain it, we won't be worrying about what that other thing it also does. You know, we'll just concentrate on the thing we're trying to fix or introduce. The formulation of it on the right-hand side from Uncle Bob is probably my favorite, and that's to do with just putting the things together which are going to change together. Okay, so the next one is the open close principle. So having modules which are open to extension but closed for modification. You should write code in a way that means you shouldn't need to edit it to add functionality. It's harder to break what we don't need to touch. It's easier to write functionality if we can write new code to do it. Again, though, this one, in my opinion, alludes to the fact we need to have a good understanding of the business domain. If we're going to understand what parts of our code are likely to need to be extended, we need to understand the business or the product or whatever we're working within. So again, it's not a sort of a heads down coding approach if you need to follow the open close principle. Dependency inversion principle tends to be well followed these days because of frameworks like Spring, AutoFac in the .NET world, and I'm sure others. And that's obviously dependency injection, which is not quite the same as dependency inversion principle, but an implementation of. Following this one often makes code easier to test, for one thing, and less coupled. It can lead to perhaps a mockist approach to unit testing, which has support in some camps, but I don't support that approach to unit testing. So I think sometimes we need to be careful that we get the value out of dependency inversion, but not some of the problems. The Hollywood principle, tell, don't ask. So a class shouldn't be asking lots and lots of questions of another class and then implement the behavior. It should just be telling that class to do something. So don't call us, we'll call you. Okay, my favorite, I think everyone should probably have a favorite coding principle. My favorite coding principle is a single level of abstraction principle. So this is that code within a function should be at a single level of abstraction, and code within a function, code within that function should be one level less abstracted than the method name. So in other words, you know, the name of the function or method should say what it's about to do, and the method should do it. But you don't want to understand the intricacies of how those actions in the method are done when you're first reading through it. So often this is, well, often layers of the abstraction are missed entirely, and I'll show you an example in a minute. It's also really easy to follow this one these days with IDEs because they're really great at extracting code. So when you read a method and you realize that maybe it's made up of a few different blocks, there's a quick keyboard shortcut. You type in the new name for what that bit of code was actually doing, and suddenly you've got a really well abstracted method. So you're following the single level abstraction just with, you know, a few clicks. It's really nice. So a quick example, if I was doing this in person, it'd be really easy for someone to stick their hand up. It's a little bit harder. So I'll just run through it. But an example of returning a library book, and the question is, and I'll give you a couple of seconds or a couple of minutes to just consume this. What is this method actually doing? I wrote this myself. This is not taken from anywhere, and I didn't write it intentionally badly. I just tried not to follow the single level of abstraction principle, which you often see. So just spend a minute or so just having a read through. Okay, so I'll also go through that. So to do return, I'm going to question some other things about the method, I'm sure, along the way, and I'm not massively keen on the name already. If the book's end date, again, not keen on the name, I'm having written this, I know that probably was the return date or the intended return date. So first of all, if it's not null and a new date, well, if this is Java, which it looks like, that's going to get the current date, so that's handy. So if the current date is after the intended return date, which we can infer from that. So basically, if it's late, isn't it? If it's late, then the book, then who the book's checked out to should be find 100 somethings. Then we should get the inventory and put, well, this bit's confusing, but we can probably infer from that we're using some sort of map or dictionary, and we're putting the book back in that dictionary by its ISBN code. And then we're going to find all the users who are waiting for the book. So where the user's waiting for contains the book. And for each one of them, we're going to notify them it's available. And then we're going to mark the book as not checked out. So I wouldn't say it's the worst code that I've ever written or read, but you know, it did require a bit of explaining to work out exactly what that's going to do. And if we'd have been following the single level abstraction principle, maybe we'd have written it slightly differently. Maybe we'd have actually just said what we ended up inferring from it. So how do you return a book? Well, if the book's overdue, whoever it's checked out to, you find for the late return. You add the book back into the inventory, and you notify anything that needs to be notified that the book's been returned. Now, I think there's some stuff gone on there that's more than just the single level abstraction principle, but mainly that's what we followed. We've just abstracted blocks from the method, very, really simple way, and just said what they do. We've removed the use directly of the hash map or dictionary or whatever it may have been, which was, you know, definitely a lower level of abstraction. Understanding that books are stored by their ISBN code wasn't really needed when I wanted to explain how a book was returned. So within a method, we only want to know the steps that it takes to do what the method's signature says it will do. And yeah, from a DDD perspective, is this really something that, you know, we should be handing the book to something, or should the book have a return method, or should this class be the librarian? I'm not sure. There's probably some other problems with this code. So that was a really, really short recap on just a few of the coding principles that I care about, and I'm sure you do too. There's many others as well. This presentation though wasn't just about how to write maintainable code. It was how to maintain maintainable code, because that's a challenge in its own right. So the first thing I've already mentioned, which is the architecture needs to be clean. Code bases typically correlate to some sort of deployable thing or deployable unit. If that's confused, you know, if actually they correlate to many things, or you know, it's less than clear exactly what the purpose of that specific code base is, then that causes confusion, and confusion can, you know, that will be with the whole team more or less, which probably means the code is going to end up looking confused and not maintainable. So a clean architecture to start with. What can also lead to a less than clean component is intentional misuse. I'll come back to why we might intentionally misuse on the next slide, but it is an interesting one that, you know, it could just be badly defined. It could be that we haven't got a particularly clean architecture, or maybe it is well defined, but people are neglecting it anyway and choosing to misuse components. So why might that be? Well, it might be because of the engineering experience. So how easy is it to actually do the right thing? I think fixating on this as you do code quality is really, really important. You know, make it really easy to onboard developers, make it really easy for them to make the right decisions. You know, and it's interesting what we can do. We've got a lot of tools at our disposal these days. Fantastic things like Docker make setup very easy. We have IDEs which can add all the rules in that we're going to expect, that we're going to enforce later in the cycle. We should make sure these are in the IDEs themselves. So, you know, developers aren't getting to the point where they've done all the review process, everything's gone in, they've waited for the 20-minute build, and at the end of it, it's popped off the back and said failure because you've not followed a rule that's set, or you've named something not using the right capitalization or something. You know, that should all be in our IDE. It should be easy to follow. Adding tests should be easy. And that, of course, means maintainable test code. Test code is as, if not more important in terms of maintainability than production code. Which is, on a maybe a side note, is that I find that often in enterprise projects, writing test code is at least as complex as writing the production code, and requires as much experience, therefore, in how to maintain a clean code base. Creating new components as well should definitely be straightforward. You know, creating new components, creating new repositories. Otherwise, people are going to take the easy route when other pressures are on them. They're going to say, you know what, why don't we just give this one that extra responsibility, because that's going to save me setting up new CI pipelines. It's going to save me creating a new Git repository. So make it really easy to make new code bases, new components. Yeah, the ease and the ability to refactor. So if we don't make it easy to refactor code, then large swathes of it are going to go unrefactored. We're going to introduce new patterns in the code without retrospectively going over other areas to bring them into that new world. Maybe controversially, but I think language choice is very important here. IDEs can only do so much with a dynamically typed language. So I tend to prefer, whether that means TypeScript or something, I tend to prefer giving the IDE all the help it can in choosing the language in the first place. Tooling too. So, you know, some tools require a license fee. We shouldn't, you know, naturally think that we should therefore avoid those tools. It may be far more expensive to the cost of not using those tools. Looking at test coverage at multiple levels, not coupling our tester and implementation. I alluded to this earlier, but I'm firmly in the camp of the classical unit testing over a very mockist and class-based approach to unit testing. So that's Detroit unit testing over London unit testing, in my opinion. Egoless teams, joint ownership, make sure that, you know, if we want to change some code, then we can. If anyone else in the team wants to change some code, then they can. Of course, it's a conversation at times, but, you know, we shouldn't feel that that area of the code, we shouldn't go near that, because we know what that dev's like if we change their code, or what the TA might be like if we change that bit. They wrote it after all. We don't want that. Knowledge share, really, really important. So we look at, you know, if we're in a Scrum typing approach, then we'll probably have some sort of showcase. It's also really important that we have show and tells that are internal, where people are actually looking at code and saying, well, this is how I implemented this bit, as well as the good design and code reviews. We should encourage an environment where failure is okay. You might not find the perfect design first time, but that doesn't mean we shouldn't try again. So instead of concentrating on people not failing, let's concentrate on making it a quick process to fail or to succeed. Refactoring shouldn't be seen as something that's separate from a development task. Having, you know, refactoring as we'll write the code, then we'll raise a task and we'll see whether that's prioritized to do the refactor. That always really scares me. Refactoring should be seen as just part of professional development. And the last one we're going to come back to, but it mentions technical debt, which needs management as well. And yeah, occasionally there's a refactoring need, which means we do need to raise something, because actually what would take half a day to get business value is going to take 6 weeks if we do this refactoring. So that's a slightly different story, isn't it? The next thing is just being consistent and steadfast in the aim for quality. I don't think Immanuel Kant was talking about software when he wrote this, or but yeah, we should never act in such a way that I could not will that my maxim should be a universal law. If we take that for software, then every bit of software we write, everything we touch, we should think that, well, it could be used as the example that someone else follows. So even if we convince ourselves that it's the least important bit of code, I think I'm of the opinion that we should still put a lot of emphasis in the quality of that code. We should still follow our own rules. You know, I completely understand the business side when we say, oh, you know what, we just need to get this bit out, but it's all too often used too frequently. Leads to a broken window situation. You know, you see several broken windows and somebody else throws another stone because, hey, it's just another broken window in this code base. I think that's very dangerous. So avoiding broken windows and making sure the whole building is looking clean. A consistent technical authority. At the end of the day, occasionally you need someone that's going to actually make a decision, and not just make a decision, but make sure that the team understand that decision, are going to live by that rule from there on in, so they don't need to maybe ask or again. So consistent technical authority, really important. Code review, mentioned briefly earlier, but so important, isn't it, in maintaining code? So a really good code review cycle. I tend to separate out the concept of code review, which I think of as the sort of the final PR, maybe, where someone's looking through the lines of code and deciding whether those names were consistent with things they've seen elsewhere, or even consistent with the same PR. And the idea of design review, which for me is what is much earlier and ongoing. So this is where you pick up a story, a feature, however you're working. And once you've had a think through, you grab another developer and you say, hey, could I have 5 minutes? I just want to discuss my thoughts on this. Here's the design I'm thinking of. I'm going to go over to the whiteboard and just draw some boxes and explain the types of classes that I think will be involved. And you'll get some feedback straight away then. Maybe there's a different way. Maybe there's an area of the code that you weren't aware of. You know straight away, before you've even written a line of code, you've got some feedback. A few hours later, you've written some classes. They're starting to hang together. You've written some hopefully some tests as well, and you bring maybe that same developer over and you just say, I could just do with a quick review at my screen. Let's go through this together, or remotely, as most of us are doing now. Let's go through this together and see what you think. So it's really aiming for this sort of no surprise code review at the end of the feature being developed. where, you know, it really is a final tick box, and you know, we only use the online tools at that point. The other thing that makes code review really important is just bringing up the knowledge of the team. So it's not all about the piece of code that's going in. It's about people learning and understanding more and more, because they're working with their skilled colleagues. And as something that we often do at BJSS is, you know, acknowledge that the required knowledge may not be within the team. So of course we can learn, we can read, we can look at blog posts, we can read documentation and learn, but also bringing in people from other teams, you know, have a fresh view on what we're doing occasionally can be really handy and helpful. Next one is around metrics. So I think metrics sometimes have a fairly bad name, and I've certainly seen them misused a number of times. I think we need to always remember the goal and why we've defined the metrics. And if they're not helping, then we should probably change them. They can be really unhelpful. You know, I've seen instances of unit tests which automatically generate code, or maybe used reflection to hit areas of code, so that the code coverage could be at exactly 100%. That's not helpful to anyone, but they've managed to get that through the CI processes constraints because of that. Was the rule wrong in the first place? Probably. The Sonar way is not the only way. If for those of you that are using SonarQube out the box, it has some defaults for rules. Rules require customization because every project is a bit different. And again, as soon as the rules aren't quite right for what we're doing, we tend to see lots of false positive activations of those rules, which means we can't really see the wood for the trees, and they start becoming less useful. So the Sonar way requires configuration, and metrics are there really to be measured so that we can understand and then resolve, not so that we can put hard lines into our CI process, or at least not in my opinion. So we measure things such as code coverage, because we can then be notified or see when a certain area of the code base maybe drops in coverage, and we can have a look and see why. Maybe there's been a really good reason for that. Hopefully that's already been discussed within the team. You know, maybe there didn't seem to be the value in a certain area given the integration, given the effort it would have taken. You know, that's a valid decision. So having hard and fast rules can sometimes cause problems, but metrics are useful used in the right way. The next thing then is technical debt. So with everything we've just discussed, with the best will in the world, we're still going to get technical debt in a code base, and there's lots of reasons for that. This diagram I've taken from Martin Fowler, and some of the words are my own, but it's something that you'll find at that link on the slide. So there's a couple of axes for technical debt in Martin Fowler's view, and I agree. There's deliberate or inadvertent. So technical debt can be deliberately or basically accidentally introduced into the code base. It can also be prudently introduced or recklessly introduced. So let's take a look at these things. So what does prudent and deliberate technical debt look like? Well, this is where we have a discussion and we decide that we just have to introduce it, you know, because we need to go live tomorrow. If we don't go live tomorrow, the business is going to fold. We know it's not the nicest way we've written it, but we just haven't got time right now, and it's really important it goes in. So who can argue with that, right? Because we wouldn't have a job the next day. So we get it in. We've introduced technical debt to the code base, but we've also raised the technical debt somewhere so that it can be managed. What about prudent and accidental or inadvertent technical debt? So this is where we just learn a bit more. So maybe we just understand more about the business. Maybe we understand more about the technologies. Maybe technologies change. Maybe we learn about a new technology that didn't exist when we started the project. So it wasn't something we were reckless in doing. But it was inadvertent. We didn't intentionally put this in. So somewhat unavoidable, we have to raise the technical debt. Now, what about on the other side of that line, on the reckless side? As you've probably guessed by the fact it's called reckless, we probably shouldn't be doing it. So deliberately reckless, which sounds rather scary, is, it's working. So what's the point in refactoring? I'm just not going to bother. Yeah, let's just not do it. We all have our bad days, of course, and I think some of the other things I've already mentioned should deal with that, such as the code reviews. I for one will think twice if I'm going to go for a code review, even if I've ticked it off in my head as oh, it's fine. It's been a tough day, hasn't it? And I've finally got it working. I'm just going to commit it. If I know that I've got to actually speak with someone and go through and explain my choices and justify them, then that's hopefully going to avoid me making that bad decision. About reckless and accident and inadvertent. So this is where, God forbid it, we say, so what's a unit test? So it could be a lack of knowledge. It could be a lack of care. But either way, we need to look at the cause of it, whether that's learning, and we need to fix the cause, but it shouldn't need raising because we shouldn't be doing it. So technical debt is raised, brilliant, but it's not going to solve much being raised. It needs an actively managed process. So we need a way of resolving technical debt. Now that could be that we bring a certain amount of technical debt into every sprint. It could be that we prioritize technical debt with our product backlog. Either way work. I tend to prefer the former. I tend to prefer a percentage of a sprint being reserved to resolve technical debt. I find that it's all too easy to go down the road of saying, what, we've got higher business value priorities. If we always understand that we'll be tackling an amount of technical debt every single sprint, then we don't have to have that discussion every single sprint. So technical debt needs to be triaged, prioritized, and understood. We could have a piece of technical debt that's pretty severe. It's a pretty ugly area of the code base, but if we're not going to touch the product in that area for the next 10 years, then it's probably not the highest priority. We can probably deprioritize that part. Equally, we may have a fairly mundane piece of technical debt. It'll just make every time I go into that code, it's just going to make me 5 minutes quicker doing my change. That could be really important if it's an area of the code which evolves daily. So we should be carrying out root cause analysis as well on technical debt, the same as you'd have in a defect triage process. If we keep getting areas of the code which are suffering from technical debt, then let's have a look at why. Maybe we need to change our process or adapt it. Okay, so to run through some of the things we use at BJSS to maintain a maintainable code base and avoid code rot. I hope that's been helpful and useful. I'm going to hang around for a few minutes if anyone's got any questions, opinions, or anything else. And you can see our website on that last slide. And please get in touch if you've got anything further. Thank you very much.